The rock cycle is a summarization of the processes undergone within the Earth's crust by deposition, transportation, melting, and cooling. The rock cycle is dependent on two main factors: the Earth's internal heat engine, meaning the movement of the mantle and core, this is also known as convection, and two, the movement of water, ice, and air at the surface. This is known as the hydrological cycle, and it is powered by the sun. Although you can begin the rock cycle at any phase, for the sake of this video, we will begin with sedimentary rocks. Sediments are formed when exposed rocks are weathered and eroded by waves, wind, and chemical erosion. These sediments are then deposited by whatever medium moves them. As erosion and deposition continues, the initial layers of sediments become buried and compressed under new sediments, which form sedimentary rock. Sedimentary rock often has fossils in it because this process is happening over time. So the bones of certain organisms or the bodies of certain organisms tend to get buried under that new layer. Heat and pressure allows for sedimentary rock to become metamorphic rock. The changes caused by heat and pressure are both physical and chemical. When metamorphic rock is heated, it melts and becomes magma, which can crystallize into igneous rocks, which are extrusive or intrusive. Intrusive rocks are igneous rocks that cool below the Earth's crust. These can form at tens to hundreds of kilometer depths. Because the rocks are at a relatively high heat, they cool slowly, which results in a coarse-grained texture known as phaneritic. You can see this is granite and it has a phaneritic texture. We know that this has a phaneritic texture because you can see the different minerals within it individually. Like this probably has biotite as well as feldspar in it. Oh, wow. Sorry, guys. Extrusive rocks cool near the Earth's surface. Extrusive rocks cool very quickly, sometimes within seconds, other times within years. This results in a very fine texture. A rock of fine texture is referred to as aphanitic. An example of aphanitic rock is rhyolite. Rhyolite, you can see, well, you can't see the different minerals in it. This looks like it is mostly composed of potassium feldspar, and you can see that it's fine all around. And if you were actually touching this yourself, you would notice that it's kind of is powdery because it's so fine. Sometimes magma goes through a two-step cooling process where it only crystallizes partially before moving into an even cooler space, causing the newer rock to have a finer texture than the first. This process causes porphyritic crystallization, and you can clearly see that texture in this undefined rock. Well, unidentified rock, I should say. So you can see that it has larger crystals, and then it has smaller crystals all around it. It almost seems like the larger crystals are inclusions, but this would actually be the result of two-step cooling. And because of the texture of this rock, we can infer that it was probably involved in a volcanic eruption where it was moving from that higher temperature crystallization to a very dissimilar low temperature crystallization. So this is the rock cycle. Thank you guys for listening.